In this video, I'm going to show you how to solve systems of equations with substitution. All right, suppose we have two linear equations. One says this. One says x equals 5y. Another equation says 2x plus 3y is negative 13. All right, we're trying to figure out what x and y equal. When we're all done, we want to be able to say x equals something and y equals something. And for this, it can only equal one thing. Each letter can only equal one thing. All right, well, the problem is we can't solve an equation with two different letters. So we have to somehow get rid of one of the letters. One of the variables has to go. Well, in this case, we know that x equals something with y in it. Whatever x is, it equals 5 of those y's. Well, then I can substitute. Instead of calling it x, I can call it 5y. Just like a person. A person can be a student, a person can be a son or a daughter, but they equal the same thing. So instead of calling this, I'm going to call it 5y instead of calling it x. So let's look down at this equation. I have 2x's plus 3y's, and it's going to equal negative 13. Well, instead of calling it x, what can I call it? Can I call it 5y? Okay, well, I have two of those things. I have two x's. That means I have two of these things. You see that? Two of those. Plus 3y is negative 13. Now I just solve this equation. And of course I do the distributive property. 2 times 5 is 10. 10, just throw that y in there. 10y plus 3y equals negative 13. All right, now look, I can combine my y's, can I? 10 plus 3 is 13y is negative 13. And then to solve it, I just divide by 13. And y equals negative 1. All right, let's put that up here. Y equals negative 1. All right, now, so then what does x equal? We know that y equals negative 1. So if we put this right back up here in this equation, let's just real quick see this. All right, so if y equals negative 1, listen, I can take this negative 1 and put it in either one of these equations. Do you know which one I'm going to choose? The easiest one. X equals 5y. Well, what does y equal? Negative 1. So x equals 5 times negative 1, which that equals x equals negative 5. All right then, let's put it up here. Negative 5. Now, if you want to check it out and see if you're right, why don't we just do this? What if we say, let's go to this equation now. 2 times x, what's x? Negative 5. Plus 3 times y, what's negative 1, equals negative 13. Well, what's 2 times negative 5? Negative 10. What's 3 times negative 1? Negative 3. I'm not going to put plus negative 3. I'm just going to say negative 3 equals negative 13. Okay? Two numbers. Negative, negative. I'm just putting those together. Negative 13 equals negative 13. And that checks out to be correct. So when I'm solving those, They're my answers. They're the correct answers. All right, let me do another one for you real quick. Let's say, take notes on this, guys. Write this down in your notes. Let's say that y equals 2x. Y equals 2x. And x plus y equals 7. Do you understand that nobody can do this problem? Do you know that no one can do x plus y is 7? Because x can be 6 plus 1, x could be 5 plus 2, y could be 3 plus 4. There's too many numbers. There's too many answers. So in order to solve this problem, I'm going to say, if y is 2x, then when I get down here, I'm not going to say y. I'm going to say 2x, because then my variables are the same. I can add them together. All right. So instead of, I'll just write this, x plus y is 7, but I know that y is 2x. So I'm going to say x plus 2x is 7. Okay? Well, what is in front of that? Isn't it an automatic invisible 1? All right, 1x plus 2x is 3x equals 7. And I just divide by 3 on both sides. And x equals 7/3. X equals 7/3. Can I show you what 7/3 looks like? I'm going to show you what 7/3 looks like real quick. If I have something and I divide it, sorry guys, if I have something and I divide it in 3 parts, there's 3/3. Well, that's not 7/3. All right, let's do it again. Well, there's 3/3. By the way, that's one whole thing, isn't it? Well, that's not 7 yet. All right, here's another. I have to make another whole thing and divide it in thirds. But this time, how many am I going to color? Here I colored 1, 2, 3, 4, 5, 6. But here I'm only going to color 1. That's 1/3. So 3 plus 1 is 7/3. Another way to say that, 2 and 1/3. All right, well, I just thought I'd throw that in there for real quick. All right, now we know what x is. Let's see what y is. If x is 7/3, y is going to be 2 of those guys. All right, watch. Y equals 2 times 7/3. What does 2 times 7/3 mean? Doesn't it mean that you add 7/3 2 times? So I can go like this, 7/3 plus 7/3. What does that equal? 7 plus 7, that equals 14/3. So y equals 14/3. Well, what does that equal? Well, if I divide 3 into 14, that goes 4 times 4 whole things with the remainder of what? 2. 2/3. So now I know that y equals 4 and 2/3. When I add 7/3 plus 4 and 2/3 together, 7/3 plus, I'll just say 14/3 for right now. 14/3. 7 plus 14 is 21. I have 21/3. When I divide that, I get 7. So my answer is correct.